Okay, so in today's video we will cover 1800 series of Huawei hardware, 1800 OSN series Huawei hardware under wavelength division multiplexing, which is a transport technology. So in that related hardware of 1800 compact box. Okay, so DWDM boards of Huawei. So there are many categories of the boards. We will call these boards as well as card interchangeably. So please adjust, because in Huawei all documents it is written boards, but some of the other equipment they call it card. So we have different type of boards here. So there are transponder boards, then tributary boards, then line boards, and then there can be further different type of line boards which can have universal line boards. Then packet boards, which is basically used to talk to the packet technology, means mostly at L3 layer. And then TDM boards, which is all old transport technologies like SDH, SONET and other transport. Then optical add-drop multiplexing boards. That is the basically building block of any DWDM. So add-drop multiplexing, and then add-drop with the reconfigurable type of add-drop multiplexers and de-multiplexers, and the simple terminal multiplexer and de-multiplexers. And in DWDM, because we use the technology to send the signals from one place to far away place, and there are fiber losses, and to mitigate or to improve the signal strength, we will have amplifier boards, then control and switching and timing boards, which is basically the main in the any node to take care of the maintenance and to do the configurations. We will have control boards, and for protection and other related services which is required for reliability, we will have switching boards. And we can transport the timing like clock, so we can transport especially for synchronous type of network like SDH and SONET. Then you will have optical supervisory board channels. So in a DWDM chain, when we will send the signal from one place to another place, in between there will be so many nodes. So rather than arranging a separate data communication network, there is arrangement of putting additional channel along with the main signal in the DWDM at a different frequency. So then those are supervisory channel, we will call them. Then there will be auxiliary boards, so which have multiple functions of communicating to the NMS, having like Ethernet port, and having option to connect to another network element in the same location. And then there it can also take care of some housekeeping input alarm and output alarms. Then optical protection boards. So protection can be also achieved by just switching the whole composite signal, which is multiplex. So that is like layers, one kind of a protection which protect all the channels, all the lambdas, all the wavelengths running on particular direction. Then for monitoring the health of the multiple channels, there is a board which is a spectrum analyzer board. So just we are moving to the next slide. So we start with the multiplexer and de-multiplexer boards. So the basic function of multiplexer and de-multiplexer is to in multiplex side, combining multiple frequencies and sending them or transporting them into one fiber. and at the receiving end, at the B end or any other end, just receiving the composite signal and distributing or demultiplexing all those frequencies or wavelength and sending them to a different destination, and which is the basically the main DWDM or WDM. So there in that series, you in 1800 OSN series, this is a model of the particular series 1800. So you have multiplexers where like DFIU, so D is dual fiber interface unit. The main work of this multiplexer and demultiplexer it is together is to combine the whole others required traffic channels plus supervisory channel and do the reverse at the another end. And then there is another different type of DSFIU. There is just slightly difference in terms of the properties they have, so I will cover them in separately. So all are FIU means they have slightly different advantage over each other. Otherwise the basic function is to just multiplex and demultiplex the supervisory and other composite signal which comes together from other multiplexer board. Then X40 and EX40, these are multiplexer demultiplexer cards. So E is enhanced with having additional features. Then ITEL is another type of multiplexer demultiplexer card, which is interleave card we call it. The main function of this card in Huawei or in major equipment is combining 240 composite signals to one final AT channel, and doing the same thing means from one composite AT channel making two separate 40 channel each. So that is the main function of ITEL card. Then in terms of reconfigurable optical add drop, we have WSDM4 and WSDM4 and DWSS9. So these are we can configure them. You can configure the wavelength by having four-way, three-way like that. So the main function of them is to have branching. Also they can work as a normal drop and add mux for few channels, and in combination with the basic DWDM boards, which is X40 or EX40, and combination with WSDM, this is wavelength selector multiplexer demultiplexer with 4-direction board, you can achieve the drop and the branching. Then there are additional multiplexer demultiplexer boards based on the requirement. So sometime we may not require the lot of channel to be dropped at particular site, so there are different type of multiplexer demultiplexer or only multiplexer or only demultiplexer boards. We can check their detail, but the fundamental remains the same. Only thing that number of channel dropping they will do less or more. So this goes on multiplexer MR card and so many type of different multiplexer and demultiplexer cards. So based on the user requirement and traffic requirement and design, user can order it. So now we basically will cover that the major boards. So where is EX40 or X40, that is 40 channel mux de-mux board, and this is the basic signal flow working principle signal flow diagram. So this board will have 40 channel input if we are using as a mux board. So 40 channel input and then one is final output. Okay, this board is shown two way. Actually this board is shown, this line is shown two direction. It means this same board can be used as a multiplexer as well as demultiplexer. So if you are using, that's why there are every time two boards. So port is called multiplexer demultiplexer number 1, and it is both directions. So but in one case you have to say take it M01, then it has to be out arrow. If you want to take it demultiplexer, then this arrow line will be to inside. Then for monitoring purpose, there is a monitoring demultiplex signal and monitoring multiplex signal. So if we are using this board as a multiplexer signal, then any monitoring of a spectrum or to check the health of those individual channels, for multiplexer we need to use this port for monitoring. And if we are using this board as a demultiplexer board, then we should connect our spectrum analyzer or that spectrum analyzer board to MOND. So this is one at a time, because this is a directional splitter. So the small amount of energy out of the total signal is split, and then monitoring is done. This is a reference monitoring because this signal is not the full signal, and accordingly software will give us the correct reference analysis. This board X40 or EX40, from front they look the same, almost the same. There is slightly design change based on the time of the design. EX is enhanced board. So this is the latest board. We use generally this one, and there are you can see 40 channel. There are 40 channel. And there is one MOND and MONM. There are two monitoring, but we have to use one at a time based on what type of the purpose it is being used for. And then final there is a line. This is also non-directional. Yeah. So now moving to some of the specifications of these boards, which we should take care in terms of taking care of operations. That this is the frequency range, which is two frequency range. So for 80 channel we need to use two EX40 or X40. So one will work in this range, another one will work in this range. So we just if clearly check it, see this is 192.10 to 196.00, and the unit is terahertz. So this is called even frequency, even channel. And another set of 40 out of this range, which is starts from 192.15 to 196.05. This range have another 40 channel, which will be called odd channels. So the card which will be used for even is called EX40 even, and this will be EX40 odd. Channel spacing in 140 channel EX board is 100 gigahertz. So in a DWDM, don't confuse, in DWDM 80 channel we say the channel spacing has to be 50 gigahertz, but in each EX board, because it is only carrying 40 channels, so adjacent channels are left over, so the spacing becomes just double. So that will give you 100 gigahertz. So the line boards to any MUX or de-Mux port, the insertion loss is less than or equal to 6.5 dB, and isolation, channel isolation in terms of dB is greater than 25, and non-adjacent it is greater than 30. So this is the in the spectrum, power spectrum, if we see the power. So the isolation means how far they are Okay, then in reflectance of this board is less than equal to -40. So reflectance should be less always. Polarization, it is less than equal to 0.5 dB, and it can work like no nanometer per centigrade is less than equal to 0.002, and the maximum channel insertion loss difference is less than equal to 3. So the insertion loss which is mentioned here, that it is less than equal to 6.5. So it is less than equal to, but the difference between the insertion losses of any channel should not be more than 3 dB, because that is the specification. Okay, so less than equal to 6.5. So some channel insertion when entering to the line port and going out from any MDX, X can vary from 1 to 40, can be less than should be like somebody is 4 dB insertion, somebody 5 dB, somebody 3 dB. So the variation in the insertion loss is not more than 3 dB, means should be less than equal to 3 dB. Then your card, VEX card or X card, X40 card is working fine. Here for understanding purpose, another DWDM box, but all DWDM Mux boards are same. So just I have pasted here one picture. So from inside it look like that. The Mux component is this one only, and these 40 channels are coming and entering into it, and then finally one output which will be the line output going out, and there may be another like monitoring only. So otherwise 40 input, one final main output, and there can be monitoring output based on the design. So in Huawei EX40 we have 2 monitoring, 1 line, and 40 main channel. So the next board is amplifier. So amplifiers are required to send the signal at a far distance, because signal gets degraded when it passes through the fiber. There are different type of fiber, but in general use this is G652 fiber, which is having a fiber loss of 0.2 dB per kilometer and a splicing loss of 0.02 dB per splice. And the connectors, based on the type of connectors we use, for ferrule type, FC type connector, it is 0.5 per connector. So based on that there will be losses induced, and to compensate those losses amplifier cards are used. So in 1800 series there will be there are 3 type of amplifiers. So BASI and OBU and OPU. So we will go through them. OBU is the main amplifier which is used generally in the 1800 series. OBU is actually 2 type. It is based on the hardware version by Huawei. So there is TNF1 and TNF2. So in TNF2 the difference from TNF1 is to have additional variable optical amplifier. So EVOA means embedded. Embedded means inside. Variable optical amplifier means you have one component added in the card itself, so which can be used based on the requirement. If signal is very high, sometime you can use this embedded variable optical attenuator to reduce the power. And we will go through OBU in detail much, because it's a single stage, and that's why you cannot do much in terms of gain reduction. This is a fixed gain, and the nominal gain of 1800 OBU is 23 dB, and it's a fixed amplification amplifier. So here we go. That is the OBU working principle and signal flow and front panel diagrams. So in terms of working principle, this is like no, you give any like no signal. So EDFA works in C band, and for this specification you will see it further, but it works between 1629 nanometer to 1662 nanometer range. So between that, any optical wave, if we give to this amplifier, this amplifies the signal, which I told it the gain is 23 dB fixed, and it send this out. For monitoring purpose of the health, we can have like no spectrum analyzer or the board analyzer. So this is a monitoring port, which is 1% of the main signal. So 99% signal goes out here, and 1% is here for monitoring purpose. And this is TNF2 working principle diagram. So there you have this additional component. So just mind it, this component is not having as such any dependency on working with other part of the board. This is just additional feature. So it's a compact, in the compact design, there is an additional feature added. In case you want to use it, you can use it. If you don't want, you may not use it. So this is not like no combined, this is separate unit which is designed together for saving space, because in earlier versions of hardware design there was separate board which was occupying one slot of any subrack, and subrack space is very much expensive in terms of having the more space. Then finally it is related to commercials to buy more space from any supplier or having your own space. In front panel it look like this. OBU, there are status indication and service indication LEDs, and you have caution because this is a having laser, so that will be always there. And this monitoring port, so this monitoring port is this port, and out and in ports. So in, this is the in, and this is the out. So they are given together, but signal goes in, then gets amplified in the inside hardware, which is just EDFA amplifier, EDFA unit, and then comes out. And VIVO means variable input and variable output. This is separate one. Okay, and then actually it look like from a different view, it look like this. So this is all fibers. So in and out, fiber goes in, then gets amplified, and then comes out as a out function. And VIVO, there is a, on the board itself there is an additional component which attenuates the signal. And monitoring board, so you will see a lot of circuitry here. That circuitry is to monitor the variable attenuator, and to have communication with the controller board, which we will cover later on. So there is a controller board which controls this board, and that controller board is finally controlled from the NMS. In Huawei case it is U2000 actually. And every board, because it has to be controlled, there will be circuitry, so it needs power. So always in all the boards you will have this power option. And in backplane it is also connected just for communicating and controlling, or alarm flow, or the because this is, there are power also, so there is a option of checking how much power I am getting. This is pin diode, and this is the block, there will be current, and there is another pin. So there are option at input as well as output to check the optical power levels. This is the specification of OBU board. Yeah, This is the specification for OBU board. Wait a minute. Control F11. Sorry. So let us continue this. This is the specification of OBU board and the variable optical attenuator embedded with it. So the main thing is these are the very general thing, that what range it works, and what is the input and output range. This is one which I would like to highlight, is the total optical output power is 20 dBm. So this we need to take care of very well while we do all the O&M or even designing, because sometimes we feel like there is a gain and it should go, but if the total output power is crossing 20 dB, and even after that you try to make the adjustment in the input signal, nothing will change, and the amplifier will reach to saturation, and some or all channel may get problem, they may go down. And based on this, there are a lot of specifications given here, but this is the main thing. So if we know power calculations in dBm, then this is the one which defines everything. So that 20 channel, if it is designed for 80, so the total output power cannot be more than 20, and based on this per channel output is designed, which is 4. So in OBU case, per channel output per channel power should be 4, and input will be in the range of like -32 to -19 for 40 channel. Means if you just only want to use this OBU board for 40 channel, you can go as maximum as -19 dB per channel. So that -19 will make that 40 channel power output with the gain, the output will be around 20. That's why this all calculation is interrelated. So in 80 channel system, that per channel power should be in the range of -32 to -22. So the nominal, so nominal means the good one will be this range. So in 440 channel 19, so this is 19 -19, sorry, and for 80 channel it should be near -22. So this thing, while we do the maintenance, we should take care of it. Yeah. And maximum output per channel, which we have already seen. The noise figure is less than equal to 6. Channel gain is 23 dB. This is the OBU specification, OBU board. Gain flatness is less than 2 dB. Means the gain for per channel, because if there are, let's say, 40 channel, all channels will not be added 23 dB. It is not simple mathematics. Some will add less, some will add more, because EDFA is a kind of amplifier where gain is not flat. It is uneven slightly. There is a non-linearity in terms of getting the gain output. So the best you can get is that difference of gains in total number of channels is less than 2 dB. Pump leakage input, this should be less than 30 dBm. Then in reflectance should be less than 40. Output at output port and input port, both reflectance should be less than -40. And it can tolerate maximum reflectance is minus up to -27. If more, then it will start creating issues in terms of performance of the channels. And that EVA, which is the additional embedded component, that is the insertion loss. So it will, because it's a component, it will insert a loss which is equal to less than or equal to 1.5 dB. So even if you make it 0, there will be insertion loss. So if you don't use any VOVI insertion loss, then still there is a loss in the component itself. and it can go with the range up to 20. So you can insert a loss up to 20 dB, and the adjustment accuracy. Okay, so if you like 0.7 attenuation for less than 10 dB, less than equal to 10 dB, and 1.5 attenuation for greater than 2 dB. So that is the accuracy of adjustment, in terms of going. So I have noted it. I have already told that maximum output power. All calculations or all this big sheet is dependent only on this. The mostly figures are dependent on this maximum output power. Only the reflectance is the separate thing, and gain flatness, that is the design accuracy of Huawei. Okay, so now let's move to the next slide. So now we have next board, which is OTU board. So OTU board is optical transponder unit. As such, there is another OTU terminology in OTN technology, that is optical transport unit, but when we talk about board, it is optical transponder unit. So the main function of transponder is to change the wavelength. So if you give any wavelength input, it can change to another. So that is also not fixed. It is based on the design. There are boards which output frequency you can have of your choice, but otherwise there are fixed frequency optical transponder units as well. So then this can take any, it can many services it can converge, means can make together and send. And this is ALS. ALS is another feature which we'll study afterwards. The next now is that in the series of OTU board, this is the one type of board which is ELOM. So ELOM board, so we will study the nomenclature. So it's a line board having octa. So this is the second name alphabet is how many boards, and M. So first let us study the naming. So if L means this is a OTU board, that is the main thing. Then this S means this is one S, but there can be so many alphabet. S means single. So in ELOM cases it is O. So this is LO 8 boards, octa. Okay, and then there is a C. So the meaning of C, this alphabet is if A, then that is 10G. X indicates that OTU2. C indicates that service at the maximum rate, OTU4. Okay, so ELOM. Then there is another nomenclature. T indicates board and terrestrial board, what type of CF we use. So now I go back. So ELOM, the main function of ELOM, it's wavelength conversion, service conversion, and ALS. So a front view look like this. So there will be 8 port, and that multiplex the signal into 210G. There's another view of this, and this we have already studied. We can see the block diagram or how it works. So there will be optical to electrical converter. So you will have 8 input, 8 output, means one RX1 and TX1 will make one port, and then it encapsulates the signal, and finally it sends optical to electrical outside. in our network we don't have this kind of a board as of now. LDX board. So LDX board, this is board converts two 10G services signal into 2 OTU2 or OTU2E. So it is like 2 to 2. So 2 10G input, 2 10G OTN output. Okay, and it's dual feeding and selective receiving means you can have the switching because it is having two. So in case you want to get the switching can be achieved by dual feeding and selective receiving. Functional diagram of LDX board is like this. So you will have RX, TX, RX and TX, RX. So there are two 10G input. Okay, and then you will have, there are 4 out and 4 in. So another type of the traffic board, which is earlier we just gone through the transponder units. Now it is a line board. So the difference between line board and transponder units are that in transponder unit the traffic input, which is the client signals or the different technology signal we can say, and the output, which is OTN signal, that is the same board, and that functionality is divided into two parts. So one is line boards, which is required to which is used to send the total signal transport layer, and the client layer, that is called tributary boards, that we will come to know later on. So out of that OTU board, now to have the additional functionality and flexibility, because in OTU boards, this is once it is input you cannot do that same board, you have that output will go, but you cannot take it any direction. That is achieved by using the this bifurcation of line and the client side. So line boards are only used to transport, so you can cross connect any tributary signals into any line boards using another board, which will be the cross connection cards. So the nomenclature for the line boards is separate than those OT boards, where there are few more digits as such. TN is transport network, and there will be XX, which will be some digits, that will be the hardware version. But the main nomenclature which is useful in terms of working is start from this N. So N indicates that this is the OTN board, OTN line board, and then this next sixth, which is S, indicates here. So S in this case is single, but Q, we have Q type, so NQ we have Q, so Q means quarter, so 4, and then this 4, so this can be also different digits. This represents the service rate. So what is, if 2 means OTU 2, 3 means OTU 3, likewise OTU 4 and OTU 5, and then there are some digits in between, and then the last digit T indicates that board is terrestrial board and tunable. So tunable board means you can put different channel on this, means you can tune it by configuring it from NMS. You can make use of it as any frequency transport unit. So one of the board here in that series line board is ND2. This is one example of. So N is line card, D is dual port, 2 is OTU2, means this is a 10G dual port, means 2 10G line board. Okay, as per the nomenclature. Usage is like now before Mux De-Mux, you want to transport any two 10G signals to distance, so you put one ND2 card at A end, one ND2 card at B end, and you just multiplex it using EX card, which we have studied already, and add the another DX. The flow, signal flow, other than the common communication and control and the power supply, other than that, this is the main is that there will be only connection with the cross connection unit. So N into this is a back plane, it is connected because it has to take the signal from any of the tributary board based on the user requirement. So it has to be cross connected at electrical level. That's why it is connected to the bus. So backplane bus, there is a bus, data bus, where with the connector this board is connected in the backplane. And then you have finally electrical to optical. So that is for the muxing purpose and demuxing, coming from demuxing. So to 10G. Another line board is NS4. So NS4 nomenclature is line board, single port with the speed of OTU4. So means it's a 100G board. Okay, so that board look like this. So only single port board, and the usage of all the line boards are almost same. It is before multiplexing and after demultiplexing. The working principle is same, but it can have multiple because it's a OTU4 which is 100G, so it can have a lot of hierarchies, means you can have a lot of combination inside it, which we can study separately. But you can have, let's say, 10G in 100G, or 80 1G, or like 240G, like that kind of multiplexing you can have in 100G board. Universal line boards. So universal line board, UN will be the symbol for universal line boards. Okay, and so if it is UN, then it is OTN and SDH. It means this board can support OTN as well as SDH technology. HN meaning is OTN and SDH. Oh, sorry. So UN is OTN, SDH and packet. HN is OTN and SDH only. So in our network we have UN type. So universal means which can support almost all the technology. S is again the number of ports, and this one is the speed. So on the same line you can have this type of HUNQ2. So H is we need to check, but UN universal, Q 4 port with OTU2. Okay, so likewise let's move further. So there is a UNQ2 board. So this is universal 4 port of 10G each, or OTU2 each. So OTU2 and OTU2E, they go together. So OTU2 is enhanced, which is having slightly more speed than the normal OTU2. The uses is the same. The front panel looks like this. 4 ports are there, and they are similarly connected to the bus and the control and all control communication units. Now the next category of the boards is system control, switching and timing boards. So these are common boards, so which is required for the unit, for the network element to run, because system control board is to be used to control and configure and communicate. Switching is basically used to have the SNCP type of switching to achieve the reliable resilient network. And timing boards, if your network runs some synchronous services, then you need a timing board. So SCC, this is the basic building block of SCC, system control and communication board, and this board in 1800 also have the functionality of OSC. So this board is made of two boards actually. One is supervisory board as well as control boards. So this is SCC in 1800. So this works with NMS, and it can manage. We can manage through this board the network element, and it processes all the overheads, and it have two supervisory boards, so it can talk two direction to any neighbor devices of Huawei. So DCN function, that means because it is having OSC board functionality features, so it supports the data communication network. Okay, so let's move. There are two type of board. ST2, this is a bidirectional, so supervisory and timing board of two ports. AST, advanced supervisor and timing boards with 4 ports. So this is AST4 is having 4. So AST1 or 2 or ST1 2, this is just the change in terms of number of ports it can handle. And AST, because it is advanced, there is additional feature it can handle is having the internal OTDR. So if you use the proper SAP, then in this board and you have the required license from Huawei, you can use this board for finding out the fault by using advanced OTDR function. So it can, because AST signal gets combined to the FIU board, so the OTDR. So means in the live network you can measure the distance of the fault, or you can measure the quality of the fiber. So there are specifications. So only I would like to highlight here is the AST board, like this SFP type. If you use this type, 150 kilometer means it can send the signal to a very far distance. So 150 kilometer is based on those specific fiber we use. And this works in the range of 1504.5 to 1517.5. So generally they works at 1510. Launch power for this board is 0.52 plus 5 dB. So this can transmit very high power, and receiver sensitivity is quite okay. So the overall range, if it is the best card, means it can transmit 5 to -41. So it can work around on a span which is having the maximum loss of 46 dB. Then 80 kilometer, -4 to 1. These are just the specifications. Overload side, all are almost between -8 to -10, which in DWDM should not be the scenario, because DWDMs are used for long distance transmission. So in AST or AST, signal flow is same. The receiver signal is being processed, and each port is speed is in 1800 is 155.52, which is a SDH STM1 rate. In AST4, the only difference will be in terms of number of ports. So you can see the front view and the signal flow. Okay, so the another board where we wanted to have the switching is OLP, Optical Line Protection Unit. So this is like dual feed selective receiving type of board. So this board, once it given signal, the signal is splits into two. So it's dual feed. So it's a hard dual feed. There is no switching here. So half signal goes here, half signal goes here. So if this signal is X, TO1 signal will be X minus 3 because of the dB calculation. So if you divide any signal by 2, it is reduced by 3 dB. dBm. Okay, same way, like in the receiving side, the signal is available from two direction, and there is optical switch. So based on the quality of the signal and the condition, the optical switch takes the decision and latches to the direction which is best. Or you can define it, you can force it. There are so many features from NMS you can do it. Other than that, the basic, there will be power because this is having active component, and in backplane it is connected for having the communication with the controller board, and in turn having the communication with NMS. The uses, there are actually different uses of optical line board. You can use in the final composite, you can use OTU to OTU. So this is one scenario is like pasted here, but there are so many other uses of line board. It can use between client to client. It can means you can do the client to client signal the protection. In terms of specification, because this is not a very intelligent board other than the optical switch, so only the specifications are related to the insertion loss. So from TI to TO, any is around less than 4 dB insertion loss. Typically it is 3. And from receive to RO, so this is because optical switch. So optical switch have the standard losses is 1.2 dB, and so it is mentioned here less than equal to 1.5, which includes the design. There are different optical switches. It's a mechanical thing, so cannot be fixed one. So it can work in the power range of -35 to +7, and wavelength it can work 1260 to 1640, which is not a worry because it's a quite a wide range than the DWDM range which we use, because we use only C band. This is a wider than that. And the alarm threshold, so means if there is a difference between primary and secondary at the receive end, the alarm will be generated if the difference is more than 3 dB. And the switching means it can switch the signal up to 5 dB. So the primary and secondary receive difference should be less than 5 dB, then only it can switch. If it is more, it is not guaranteed. Sometime it is slightly more, it can switch, but it is not guaranteed. So that this is the main thing which we should be taking care, that the receiver signals should be in the range of 5 dB. So this the 5 dB, this is the main thing we need to take care in terms of this board. Okay, or rest we have already studied. This is spectrum analyzer board. So OPM, there is optical performance monitor. 8 means it can monitor 8 signals. So this is like kind of a selective switch. So at a time you can only monitor one signal from this OPM board, so which you can switch. So when you select from the NMS, automatically command goes to the OPM board and it select the required. So at a time you can only monitor one signal, but you can monitor 8 such signals remotely if you connect 8 input. So mostly at the output of the amplifier we monitor, and there are some other mux de-mux point where we can monitor the board. So this is the additional board to see the health of the channel, to see the health, how much difference in terms of gain, flatness in the channels. Usage you can have anywhere. So this is typical use is output, because mon port is the reference input for this OPM board. Auxiliary board, which is the another it can have features like alarm in out, then you can have sync, then you can have some timing. So that's all. This completes the major 1800 chassis. 1800 node series. So just to add here, there are three type of 1800 chassis. So 1800 type 1, type 2 and type 5. So that completes the complete